Welcome to everybody to my channel. To clear the concepts in GATE Engineering Mathematics, and two videos are already uploaded. One was preliminary and second dealt with the subject of linear algebra. Until now we have learnt in the previous two lectures geometrical representation of vectors and matrices. We have gone into the details of geometrical representation of vectors and matrices, and we went away from the traditional way of applying formulas and getting the geometry. We applied geometry, we created geometry, then from there we obtained the formula. This is what was done in the lecture 1 on linear algebra. Then we went into the details of matrix operations. Something is there physically, it is operated on something else, then what happens? That is the curiosity question for any scientist or engineer. In this aspect, we took one matrix, the physical meaning of the matrix, and we operated another matrix on it. And the operation can be either an addition or a multiplication. We have operated and seen the results geometrically, and we found that under matrix operation under addition, matrix operation is commutative and associative, whereas under multiplication it is associative but not commutative. Next, we went to the details of matrix vector operation. One is matrix operation, another is matrix vector operation. When a matrix is operated on a vector, what happens to the vector? That's what is explained in the lecture 2, and from that we got the physical meaning of eigenvectors and the eigenvalues physical meaning. From the eigenvectors and eigenvalues physical meaning, in the next lecture, in linear algebra lecture 3, we want to delve into deep aspects and deep meanings and deep understanding of eigenvalues and eigenvectors. Once the operations are over, once the concepts of the operations are over, then we will go into the physical calculations of solving the simultaneous equations, then linear equations and other aspects of the linear algebra. This is made in such a way that we will clear the concepts first geometrically, then derive the formula and go back to apply them in engineering mathematics. In that way, the total course is framed, and these three topics we have covered till now, and this eigenvalues, eigenvectors, it will be dealt in detail for another two lectures. Best of luck to everybody. Please look into my lectures, and lecture 1, lecture 2, please go back and see them in my channel. And second thing, please view them, review them and subscribe to my channel. If you feel it's worth to see and it is worth to subscribe, kindly subscribe and encourage me. And I wanted to do my level best justice to all the engineering graduates in understanding the engineering mathematics for applying it in day-to-day and in engineering designs life. Best of luck. Let me start the subject. Eigenvectors and eigenvalues, I will take it forward. Good morning everybody. It's Ramchandra from the channel GATE Engineering Mathematics by an IIT alumni. In the previous two lectures, I had explained the process of geometrical representation of matrices and also vectors and the relationship between the matrices and vectors and their usefulness. In addition to that, from geometrical representation, we have defined many types of matrices like diagonal matrix, upper triangular matrix, lower triangular matrix, determinant, eigenvalues, and eigenvectors. Today, we'll go in depth about the eigenvalues and eigenvectors. It is linear algebra, lecture number 4. In this, I will be taking up eigenvalues and eigenvectors in depth. First of all, I have given two problems to you. It's lecture number 3 and asked you to find out whether certain matrices which I have given you have real or complex or same eigenvalues or not. And another problem also I have given, if two matrices are there, if they are not commutative, then whether their eigenvalues are same or not. For these two, concept is required. Let me start with a simple 2 by 2 square matrix. Let us say that square matrix P is equal to 1, 2, 3, 4. Next, another matrix, let us say Q, it is also a 2 by 2 square matrix, that is 5, 6, 7, 8. Let us say. It's an arbitrarily I have taken. Nothing, anything that I have to take this way only. Now, here what happens? Let me see the operation multiplication PQ. PQ, what happens? What will be the value of PQ? This will be 1 into 5 plus 2 into 7 and then 1 into 6 plus 2 into 8, 3 into 5 plus 4 into 7, 3 into 6 plus 4 into 8. This becomes 5 plus 14, 19 and 6 plus 16, 22 and 15 plus 28, 43, 18 plus 32, 50. Now let's go for QP. This is a matrix operation. Huh? What will be the value of QP? 5, 6, 7, 8 multiplied by 1, 2, 3, 4. This value will be 5 into 1 plus 6 into 3, 5 into 2 plus 6 into 4, 7 into 1 plus 8 into 3 plus 7 into 2 plus 8 into 4. What will be its value? Just see what will be its value. Five plus 18, 23, 10 plus 24, 34, 8 plus 7 plus 24, 31, 14 plus 32, 46. This is the same question I have given you in the previous class. I wanted you to find out whether eigenvalues of these two matrices are same or not. These two matrices, whether the eigenvalues are same or not. This is the product PQ and this is the product QP. PQ is not equal to QP. Implies P and Q are not commutative. In the simple problem only, how many concepts we are clearing, just see. Now, eigenvalues. What are the eigenvalues? Eigenvalues are the values when a matrix is operated on a vector that produces a vector which is multiplied by a scalar quantity. That means PQ operating on a vector x gives lambda into x. This is what is eigenvalue for PQ. And second, QP operating on x gives you lambda x. Geometrically, we have represented it, and PQ is, let us say, try to understand the concept. What is 1922? A point here, 19 and 22. And what is another point, 4350? Something here and here. It is not to scale. Please forgive me. This is one vector and this is another vector, and both are representing a matrix. Now you just see. What is the slope of this line? 50 divided by 43. Its slope come to 1.162. What is the slope of this line? 22 divided by 19. 1.157. From this equation, if the eigenvalues are same, then the equations PQ x minus lambda x should be equal to QPX minus lambda x. From above, we can write 19 minus lambda into 50 minus lambda minus 43 into 22 should be equal to 23 minus lambda into 46 minus lambda minus 31 and 31, 34. Now let us see. This equation we have got from our previous discussions. The determinant of a minus I lambda should be equal to 0. That means if the eigenvalues to be equal, the determinant of PQ should be equal to determinant of QP. Now, what is the value of determinant of PQ? It is 950. By looking orally, we can write 69 lambda minus 946. For this, it is 1058 plus lambda square minus 69 lambda minus 1054. With this only you might have understood from this equation. It is very simple to show. This will be lambda square minus 69 lambda plus 4 is equal to 0. Here it will be lambda square minus 69 lambda plus 4 is equal to 0. That means PQ, for finding eigenvalues of PQ, this is the equation. For finding the eigenvalues of QP, it is the equation. Now, can we finalize? Take it as a homework. Can we finalize that even though two square matrices do not commute under multiplication operation, can we say from above that eigenvalues of QP and PQ are same if the matrices are non-commuting matrices are P and Q? Please do it. Either do it by induction process, mathematical induction. You take a 3 by 3 matrix, then you find out if QP and PQ for a single element, it's already there. QP and PQ eigenvalues will be same, even though they are not commuting. Then you find out for next 3 by 3 matrix also. Take an example as I shown you. I have taken 2 by 2 matrix example. Take a 3 by 3 matrix simple example and do it, and show that this square matrix, even though they do not commute under multiplication operation, eigenvalues of and QP and PQ are equal. This you please show. Now let's go to the next discussion. These are all very useful discussions. Please be attentive. Now again on eigenvalues only. Let me take a 2 by 2 matrix P11, P12, P21, P22. In this, upper triangle will be, upper triangular matrix will be P11, P12, 0, P22. Lower triangular matrix that will be P11, 0, P21, P22. Now diagonal matrix, similarly you write for 3 by 3 matrix also. That you take it as a homework and write for 3 by 3 matrix. For all these, determinant is equal to P11 into P22. This is the determinant. Now you tell me, let us try to find out the eigenvalues. From the geometrical interpretation, we could find out that determinant area of the parallelogram is equal to product of the eigenvalues or product of the elements in the diagonal matrix or upper triangular matrix or lower triangular matrix. Now let us see. Let's calculate. Let us take 1 and do it for others similarly. P11, P12, 0, P22. Let us take this as it. Upper triangular matrix. Then what will be for eigenvalues? What we have to do? P11 minus lambda, 0, P12, P22 minus lambda. This determinant should be equal to 0. That means P11 minus lambda into P22 minus lambda is equal to 0. That means lambda 1 is equal to P11, lambda 2 is equal to P22. What is the sum of this? Sum of eigenvalues is equal to P11, P22 are diagonal elements. Sum of the diagonal elements that can also be trace of matrix P. Then what is the product? Product of eigenvalues is lambda 1 plus lambda 2 is equal to P11 plus P22. Lambda 1 into lambda 2 is equal to P11 into P22. That is equal to product of eigenvalues. Product of product of eigenvalues is equal to product of diagonal elements in a diagonal matrix, that is equal to determinant of matrix P, but that matrix should be diagonal matrix or a triangular upper triangular matrix or a lower triangular matrix. Okay, this matrix for these three conditions: upper, lower and diagonal. Now we are going into a further very good topic where we say I have a matrix, but at site it is not diagonal, but can I make it diagonal? So that I can get the eigenvalues at site only by simple operations. Let us see. These are called as row column operations. We are manipulating the matrix. We are manipulating the matrix. For example, this is a very important topic because eigenvalues and eigenvectors, once they are given, they may be given in 3 by 3 matrix, in which you can reduce it to simple form, and we can Euclidean form, and we can get the eigenvalues very easily at a site. Row column operations. For example, I have this one P11, P12, P21, P22. Now, will there be any change in the matrix or a determinant if I deduct one row to another row? Let me see. For example, this is R1. Let me see geometrically. This is R2. And let me operate row operation. What I have done, R1 I keep it as it is, the row which I am operating I will keep it as it is. R2 minus R1, let me say. P21 minus P11, P22 minus P11, P12, sorry. What effects it will have? What effect it will have? Let us see. I take a matrix 1, 2, 3, 4 and I do the same operation 1, 2. These will remain same. I am not changing anything in R1. I am only doing operation on R2. R2 minus R1. R2 is 3, it is made as 2. And R1 here is 2, that is deducted from 4 minus 2 is 2. Do you agree? Do you agree to it? 1, 2, 3, 4. I have operated R2 minus R1. From R2 I have deducted R1. Each element separately. Then let us say step by step, let's go slowly. What will be the determinant of the new matrix? Just to see. This determinant is 1 into 2 minus 2 into 2, that is equal to minus 2. And what is the determinant of the original matrix? 1 into 4 minus 3 into 2, that is equal to minus 2. That means by row operation, the determinant has never changed. Now, can I do further row operations? Let me see. If I do from this step, if I go for again R2 minus R1, again R2 minus R1, what it happens? 1, R1 I am not changing, only R2 I am operating. 1 minus 2 minus 1 is 1 and 2 minus 2 is 0. Here also what is the determinant value? 1 into 0 minus 1 into 2. That means my determinant value is not changed. Determinant is not changed means my other properties for a diagonal matrix or upper or lower triangular matrix, eigenvalues are not changed. My determinant is not changed. Product of eigenvalues is not changed. Now, can we further do it and see? Let us do some operations, small operations. Can I do further? Yes. R2 minus R1. Let me see what happens. Another R2 minus R1. It is going to give me 1. R1 I am not changing, only R2 0 minus 2. It is 0 minus 2. This is also R2 minus R1. R2 minus R1. Now you tell me, is it an upper triangular matrix or a lower triangular matrix? It's an upper triangular matrix. For an upper triangular matrix, what is the principle? Lambda 1 into lambda 2 is equal to product of the diagonal elements. Sum of the diagonal elements is equal to lambda 1 plus lambda 2, 1 minus 2, that is minus 1. Next, what are the lambdas? Eigenvalues is equal to the elements of a diagonal matrix or triangular matrices. What are the eigenvalues? What is the diagonal element? One is diagonal element, another minus 2 is diagonal element. In this case, what are the diagonal eigenvalues? W1 is equal to 1, W2 is equal to minus 2. That means within seconds, we could get the eigenvalues. Now, it is very simple. You go and substitute in your x is equal to lambda x, your eigenvalues, so that you can get the eigenvectors. The solution of this is the eigenvector. It's very simple. That means with the row operations, we can go to get a diagonal matrix or a upper triangular matrix or a lower triangular matrix. Try to get it. Once you get it, the elements whichever are there on the diagonal, principal diagonal, they are the eigenvalues. You take the sum and you take the product, that is determinant. And you can, within seconds, within no time, you can find out the determinant and you can find out the eigenvalues of a matrix which can be reduced to triangular matrix or a diagonal matrix. The next question comes, can we convert, question for homework, can we convert any matrix into triangular or diagonal matrix by row operations? Please go through whatever I have given, apply your mind and try to answer this question. These things are going to help you very well in your examination, and finally I will try to find out as a practice problem, I will try to find out the eigenvector. So that in detail I will tell about the eigenvectors in the next class. A sample problem I will solve today, and with this you develop your confidence. Then we will go for full level discussion on it. Let me say, there is a matrix. Question. Now I am not worried about eigenvalues. You are very easy to solve it and you can very easily get the answers for eigenvalues. 3 by 3 eigenvalue, 3 by 3 matrix eigenvalues in next class I will take up, and today I will take up the eigenvector example so that you will appreciate the example, whatever concepts I have given. Let us say a matrix 4, 5, 6, 7 operated on a vector. Find out the eigenvectors. Here, let's draw an xy diagram, xy plane, and find out this matrix. One is 4, 5. Another is 6, 7. This is 0.45. This is 0.67. Nothing is to scale, and one vector is there, xy, and this matrix is operated on it. What happens? What happens? Let us see. When a vector A is operated on X, when a matrix A is operated on vector X, it gives, as in the last class we have discussed, another vector, the X vector, whatever is there, which is acted upon by a matrix, going to give rise to, either in the stretched form or a shortened form, a result lambda into X, where lambda is the scalar. This is the eigenvalue. When a matrix acts on a vector, then that vector either stretches or shortens by a factor called eigenvalue. This is the meaning of the eigenvalue. Now, what is A here? A is equal to 4, 5, 6, 7. Correct? Try to understand. Don't mug up the formula. Try to understand. It acts upon vector X. That means 4, 5, 6, 7 acts on X is represented by xy. Let us say xy are arbitrary, and producing lambda in xy. What it is producing? It's producing lambda xy. We have to solve this equation so that we can get the value of lambda. From that, we can get eigenvectors. It gives lambda values. Now let me see how to operate it. I have shown geometrically how to do it. Now let us see mathematically. This what happens? Four, 5, 6, 7 xy minus lambda xy is equal to 0. That means 4, 5, 6, 7 minus lambda I xy is equal to 0. That means 4 minus lambda 6, 5, 7 minus lambda. For this to be 0, the determinant of the matrix should be 0. That means determinant of 4 minus lambda, 5, 6, 7 minus lambda is equal to 0. That implies 4 minus lambda into 7 minus lambda minus 30 is equal to 0. This is a simple calculation which you can do very easily with your elementary algebraic knowledge, and we found the values to be lambda 1 is equal to roots of this equation half into 11 plus square root of 129, lambda 2 is equal to half into 11 minus square root of 129. These are the eigenvalues. Now after getting the eigenvalues, what to do? How to get the eigenvectors? That is the most important thing. And eigenvalues we have got very simple way. Now let us get the eigenvectors. For getting the eigenvectors, what is the formula? Ax is equal to lambda into x. Ax, apply above values in formula Ax is equal to lambda x. Lambda you know, two values, lambda 1 and lambda 2. Matrix you know, and you are not aware of x and x. That is the resultant vector after the matrix operation. Ax is equal to lambda x, which implies, let us put a lambda 1 is equal to 1 by 2 11 plus square root of 129. Then what is Ax? A is 4, 5, 6, 7. What is x? X, y. And what is lambda? 1 by 2 into 11 plus square root of 129 into xy. From this, we have to find out the vector. Now just see, it's a simple, very simple. You just see. Left hand side what it is? 4x plus 5y and 6x plus 7y. This is the matrix we get. And right hand side what is the matrix you get after operation? 1 by 2, 11 plus square root of 129 x, and another is 1 by 2, 11 plus square root of 129 y. This is what I have explained previously in my previous classes. When a matrix, this is the matrix, and operates on a vector, you get another vector. Now let us try to solve this. Very simple. 4x plus 5y should be equal to half into 11 plus square root of 129x. Do you agree? And 6x plus 7y is equal to half into 11 plus square root of 129 into y. Do you agree? This is for lambda 1. We'll do it for lambda 2, another vector we'll find out. We are finding the eigenvector for lambda 1. We want to know the values of x and y. It's very simple. Let me take this 4x that side. 5y is equal to, this is equation 1, half into 11 plus square root of 129 minus 4 into x. What it implies? Let me say I want to make the coordinate of y as unity. If I want to make y as unity, then how can I write this equation? Y by 1 is equal to x by 5 by 1 by 2 square root of 1 by 2 11 plus square root of 129 minus 4. 4x plus 5y is equal to 4x plus 5y is equal to something. Yes, I have taken it for one is positive and another is negative. I have taken lambda 1. This is going to be my vector. This is the eigenvector. What is my eigenvector? Y by 1, or we can even write it as eigenvector as x component first 5 divided by 1 by 2 into 11 plus square root of 129 minus 4 comma 1. Please cross check if I have made anything wrong. Just please cross check. Five y is equal to 4x plus 5y is equal to so and so. Oh, here we have made a mistake. Another equation will be four, 5, 6, 7 xy is equal to half into 11 minus square root of 129 xy. Now, as a homework, you try to solve these equations and find out the eigenvectors. In the next class, I will solve this problem. It's a very simple problem, not a complicated one. And the matrix is a 2 by 2 matrix and simple value is 4, 5, 6, 7. And it's a simple problem. Please try to solve it. If you cannot solve it, please let me know so that I will give the solution. Because instead of me solving the problems, it is better if you solve the problem. I will give the hint that whatever vectors you get here, whatever the equations you get here, like if you multiply this, if you operate matrix on the vector xy, what this is going to happen? 4x plus 5y, one row, another row will be 6x plus 7y. These rows are same for both the eigenvalues. Then this will be lambda 1 into xy, or we can even write, if you take this lambda inside, we can even write a minus I lambda A minus I lambda xy is equal to 0. This way also you can write. This lambda is lambda 1, lambda 2, lambda 3. Six plus that is equal to lambda 2 into x. Now you just see 4 minus lambda 5, 6, 7 minus lambda xy is equal to 0. That means 4 minus lambda into x plus 5y is equal to 0. Another equation is 6x plus 7 minus lambda into y is equal to 0. These two equations you have to solve. That's all. These two equations you have to solve to get x and y values. And you put suitable lambdas and you try to get the result. I will give. This is the equation which I have given the total hint, and you can get the answers as. Try to get this form in this form. This is one vector. Don't go by numbers, lambda 1, lambda 2, 1, 2. You go by logic. Try to solve this problem. I have 90% I have solved it. 10% I left for you intentionally. And whatever matrix I am taking here, numerals I am taking here, they are out of my own intuition, not from any textbook or not from any examination. I see the pattern in the examination. I little bit change the pattern and develop my own content so that things are not complicated. If the complicated also things, they will be very easy to solve. They are very easy to solve. If you solve this type of problems with me, then in the GATE examination you feel that it's very easy to attend those. Please look back at last 10 years or 20 years GATE papers and also 2024 GATE papers and try to solve the maximum questions possible. As and when we are going forward with the syllabus, you try to solve the questions one by one. Now, in this class, what we have learned in toto, one is that we have gone into the detail of matrix multiplication, non-commutative, PQ is not equal to QP. To some extent we have shown that, and under certain conditions. And if even though the P and Q matrices are not commutative, the eigenvalues for PQ and QP are same. That's what we have done. And we have discussed about the triangular matrices, diagonal matrix, and also we have seen the properties of eigenvalue. Eigenvalues for a diagonal matrix are nothing but the values of the principal diagonal, elements of the principal diagonal. And we have seen about the row column operations. That means as much as possible you try to reduce the matrix, even if it is a 3 by 3 matrix or 4 by 4 matrix, try to reduce into a diagonal matrix form or a triangular matrix form, and see from that by glance you can estimate the eigenvalues. The values given in the diagonal, the values of the elements given in the diagonal are nothing but the eigenvalues of that triangular matrix or a diagonal matrix. The row operations I will take up tomorrow, in the next class rather, once I complete with eigenvectors. Now we have seen the concept of eigenvalue, and then we developed some equations and simple problem we tried to solve to get the eigenvectors, and we could get them also. Now the next question is how these eigenvalues and eigenvectors are going to be applicable for different physical phenomena, especially in quantum mechanics. They are of much use, and also in the vibrations in mechanical engineering, they are of much use, eigenvalues, eigenvectors. and they are very, very important. It is better to solve as many problems as possible. And we have also seen that eigenvectors and eigenvalues can be easily obtained for a 2 by 2 matrix, and the same principles can be extended to 3 by 3 matrix and to n by n matrix also. Best of luck to everybody. Again, happy Diwali from my side. Thank you for listening to me.